All right, this is Mr. Poggio, and you are on task number 6 of coding Corona. That means you're wrapping up your very last coding task. You had a more difficult coding task for number 5, which was adding procedures and adding sliders. Now we're just adding a graph, which is actually going to be a little bit easier. You'll see that you've already done, I know I like to make my space on look 3D, but you've already added sliders, most specifically transmission, so that you can tell your story of the theory of how you think the spread of coronavirus will happen in your population. That's that transmission slider. You're also going to have a recovery slider, and that's going to tell your sick or your red turtles to be able to recover to yellow or immune. And the transmission is just going to mean that when you have a red turtle make contact with a healthy blue turtle or agent, then you should have a random possibility, depending again on the transmission rate, if that blue turtle will turn red and become infected. So those are the sliders you added last time, and this is the new graph, and I want to show you guys what it looks like. When I hit setup, the graph clears itself, and I still have my same population, which is about 312 healthy, or 312 million healthy people in the United States, and then I have about 5 or 6% that are immune, and then a couple, maybe like 2 or 3%, so we have like 3 or 4 reds to start. I think it's 2 reds actually. And then we also have black to represent dead, very ill, or on a ventilator. And there's only one of those, and you'll see that will keep a lower value most of the time in this model. So as I'm running the model, I have a low transmission rate, and this is where I can say, hey, we didn't know about the virus at first. So even though right now we're on day 30, now 40, now 50, I think it was realistic that Easter was around the 100-day mark. So I'm going to have a high transmission rate until then, and I'm going to pause. So we're getting close to the 100-day. 50 million people is actually pretty high. I probably wouldn't make my final model that high. I'll probably find a way to keep it more around the 25 million mark, which is close to 10% of the US population being infected at the 100-day mark, which might be closer to my theory, my analysis. But now you're going to see I'm going to drop the transmission slider all the way down, and this could represent the fact that we started social distancing in America. It could represent that quarantining, or it could represent that a vaccine was introduced into the market. But being able to change this transmission slider in the middle of running code will allow us to tell the story, most specifically with the variables that are happening in our real life world, and also scientific innovation. So if I were to hit forever now, you'll see that immediately my red should start to decline because I lowered my transmission rate because we're doing social distancing around this time frame. You'll see the yellow continues to increase because that would be the immune, the red getting better. And sooner or later, the infection should get lower until, looks like we're opening up the economy and people are starting to gather in groups again, and all of a sudden people realize there's other things like maybe getting the disease could make a faster time frame for immunity, and then all of a sudden realize that was a bad idea, and our hospitals got overwhelmed, and boom, we had almost a third of the United States all infected. And again, this is my story, my theory. You should see as the recovery happens, you should see the red turn to yellow, and of course there's that yellow data increasing, meaning there's more and more and more of the immune and less and less of the infected as they recover. And here's an example of about a year out. So what is that? Close to almost 400 days, or close to a year and a little bit. Here's that first wave that we just had, Easter. And then here's what I like to call the limbo period. Let me zoom back out there, see if I can figure that out. But that would be the limbo period where maybe I can't figure it out. There we go. And that would be the limbo period until there was a reopening of the economy, where that's where there was a very, very, very fast and increased transmission rate until it slowed down again. So this is kind of my story. And this is how your graph allows you to tell that story. And when you go through this, remember, don't just do your presentation one time. Give it a couple shots, because you'll see as you do it, even myself doing this one, I found, even though I messed up, a moment ago with the graph, these things happen, and you need to get used to it and understand how you're going to describe and narrate to your specific model that you've designed with your code. So if you're going to the PowerPoint, let's take a look over here. I already have you all set up for that. Throw my video over here. but you should be somewhere around, if I am correct. We should have already added your recovery slide, and we finished up lesson 5 with our task number 5. Again, that was the harder code. Now we're just adding our graph. And when we add our graph, the whole idea is that we could have a better idea of values and probability, and what I mentioned earlier about impacting the transmission rate. So we could change that. And in doing so, you'll be able to quantify. So instead of qualitative, you'll be able to quantify data, and that will be reflected in your graph. And this is the instrument of creating a graph. You're going to do that by going to the very top, and I'll show you this really quick by adding a new widget. So you're going to edit your interface, and then you're going to click right here where it says new widget, and you're going to want to do a graph or a line graph. I'll lock my interface again. But you're going to want to do a line graph. Ooh, there's a bar graph. I didn't think that option was available. And make sure you do a line graph. And this instrumenting or counting your model, you'll see that there are specific blocks from counting the healthy, counting the sick, depending on, remember, our color coding of blue being healthy and yellow being immune and red being sick with coronavirus. But you're essentially going to be doing this coding right here. So you're going to find all these blocks in your Startlogo. For some reason, it's best when you use 150 steps, so it counts your turtles up to 150 steps as they're moving. Some people use 200. Why don't you run your code and see how it works with different number of steps? But I think if you do less than 150, you won't get the graph or the data that you're looking for. Make sure to add at the very top here your healthy population, or maybe it's your sick population, but you have to do that specifically to the colors. Again, blue being healthy and red being sick, and it's all going to the same graph. So you need to make sure you have your graph labeled and titled. This graph on this example is titled population, health, and sick. But then again, remember, you also have your yellow that is immune, and black, which represents the very ill or those that have died from coronavirus. And then I want you to test your model. That's the only code you're doing. You're literally doing this code in the World tab, and that's it. You're not even touching the Turtle tab. The Turtle tab stays the same. You're telling the Turtle to do the same thing. We're just going to quantify your data in the World tab. So you'll be doing 4 of these for each 4. And well, I mean, you just got to see if it works. You got to run your model, test your new generated tool, and execute it, and then check that system under test. And if it doesn't work, do it all over again. This is that troubleshooting you've been learning in coding over and over and over. And the whole idea, again, is you get to customize your presentation. We're researching diseases and adding a real transmission value to coronavirus. So the idea is that you can use your transmission slide as a way to show or explain how transmission rates or societal changes, social distancing, quarantine, even herd immunity, or any other societal factors have changed the speed at which coronavirus is exposed within a population, or in other words, the transmission rate. And once you've done and you've designed your experiment, you're done with coding Corona for your rough draft. You're going to send me a rough draft. Try to make it 2 or 3 minutes explaining your background, explaining what you learned about your data dive. You might even want to include your data dive slide. Tell me where we're at now in your population. So be very specific on these are values now. And then, of course, the last minute theorizing or telling me where you think the spread of coronavirus will end within the population. So I tried to break it down for you guys with 1 minute, 1 minute, 1 minute. And I think if you take a look at your final task, I wrote it up here for you as well. So as this is loading, we'll take a look into that final video that you're making, because what you did with task number 6, finishing up here, is essentially a rough draft. And all you're doing next week is narrating your video, or task number 7, your final video, 3 minutes, your final product. So we're right around the corner from being done. Just we'll review lesson 6, and just a reminder. In fact, actually, here's where I have the slide. Here's your whole idea of narrating. So if you want to use a rough draft and use it to be a little bit more specific to your final model, feel free to do so. This is slide number 92 in our Coding Corona PowerPoint. But I would say one more time, let me reiterate, about a minute on the background of your data dive, about a minute to tell your audience what you're doing with your code, why you do things with your code, and what's happening now with coronavirus, and then a minute with your thoughts and speculation of the future. And when this is allowing you to adapt to your transmission rate because of societal changes or maybe even science advancements like vaccines and things like that. Have fun with it. Remember, practice makes perfect. Give yourself multiple tries and practice. And let's make your video less than 3 minutes. That means 2 minutes and 59 seconds or less. Because then if you're doing that, we can submit your video to the Khan Academy scholarship. That's actually a large endowment or a fund for scholarship opportunities. There's over $250,000 they're giving away, and they have a contest for making a video about coronavirus for science less than 3 minutes. Oh yeah, that's exactly what you just did for my class. So your video you could submit right away to this contest, and you never know. The better you narrate, the higher quality of your video, the more information, the better vocabulary, the better chance you have of being a part of this cool opportunity, or at the very least having a really awesome video that teaches you and shows everybody that you understand code, that you're able to do a data dive and understand researching and being able to model and theorize what can happen in the future. Because I'm going to say the same thing I said to you from the last day we had in class. I think it is best to be proactive and understanding what's going on with coronavirus, not reactive. And that is you're adding a graph to number 7, and also a huge sneak peek on what you're going to be doing with your final task number 7. But this is pretty much close to the end of the line. I'll have one more video for you guys on task number 7 to talk more in detail about your rough draft and your narrating. But that's task number 6. Good luck, and make sure you get that done by the end of this week. See you guys.